Good afternoon, I'm Linda Green, and Sunshine asked me to talk a little bit about water quality trends, not really about advisories and closures. And so I'm going to do that for this afternoon. URI Watershed Watch is a long-term volunteer water quality monitoring program. We're in our 26th year right now. We started in the Wood-Pawcatuck Watershed in 1988 with about a dozen lakes and ponds. We now have about 400 volunteers monitoring over 350 sites. Oh, she's off by 100. 350 sites on over 250 water bodies throughout the state and into Connecticut and a little bit into Massachusetts. About a third of them are lakes and ponds, a third are rivers and streams, and a third are coastal waters. And all the data since the year 2000 are on our website here. We monitor quite a bit. In the field, our volunteers monitor water clarity, temperature, dissolved oxygen level on our locations more than 15 feet deep, but also in our streams, and they monitor for algae, which we measure in the lab. We monitor nutrients, bacteria, chlorophyll, pH and alkalinity, chlorides, and actually we submit to the state of Rhode Island about 20,000 lines of data each year from our program. So it's a significant data contribution to the state and rather exhausting for us to keep that all managed well. So just a little bit of education. We've been throwing around some big name words, and I know you're all familiar with it, but and this is great to talk now because I really feel like I'm building on what others have said before. And so when we talk about nutrient enrichment in freshwater or in saltwater, it's called, the big word is eutrophication. And the culprit in freshwater is phosphorus, which is not a pollutant in and of itself. It's required for life. If we didn't have phosphorus, we wouldn't be alive. And nitrogen, which is also required for life, is the culprit in salt water. And I want to stress that it's very tiny amounts could have a huge effect on water quality. They provide the food that fuels the algae and the plants in our waters. And when the algae grows, we tend to have a reduction in water clarity. And in many cases, we get a dissolved oxygen reduction too, which means the ecosystem is not healthy for fish and other living beings on the bottom. So when we talk about nutrient enrichment, we go from low nutrient, which is oligotrophic, meso, which is moderately, and eutrophic or hypereutrophic, very enriched. So one of the things I decided to focus on was two of the feeders of this and take a look at the Watershed Watch data over the years compared to last year. And so this is, and I'm going to focus right now on lakes. So these numbers here correspond to lakes in the program. They're on another sheet. And what I did was I ranked them from low phosphorus to high phosphorus. And the designations have been chosen by limnologists, people who study lakes and lake science, to determine what levels are considered low, medium, high, and very high for our lakes. And so these bars here are the average phosphorus levels in the lakes, each of these particular lakes over the years. And so you can see, and for the number here, there's about 60 lakes here. Very few are in the high, and very, very few are in the very high region. So we don't do, our volunteers monitor many lakes, but as you can imagine, they really don't want to monitor the really gross and yucky ones. So this is not a statistically set up, but it's where we have volunteers and where we can get people to go. So these darker blue bars are the differences of our phosphorus levels last year compared to the average. And what you can really notice is in only very few locations, except for our really yucky lakes, did we have higher phosphorus in 2012 compared to what we'd seen in prior years. So this is really good. And what it makes us think is, wow, well, we know phosphorus causes algae blooms in the most part, so wow, we should be seeing less algae blooms than we did in prior years or than average. Before I go to what those results are, I thought I'd talk about some studies that have been done nationally, lakes all across the country, high power statistics to choose them, comparing a study that was done in 1972 at the start of implementation of the Clean Water Act, the National Eutrophication Study, which with the 2007 National Lakes Assessment Program, where over 100 lakes in the United States were assessed. And in terms of chlorophyll, they found in between those 2 years, there was about no change in half the lakes in the country, which really kind of surprised me. About a quarter were degraded and a quarter improved, because when I kind of thought back on water quality, I always felt that for quite a while things were getting bad, but maybe what this is showing is that our environmental laws are really having some effect on the water quality. So I thought that was a kind of a nice backdrop to what we see. So when I took a look at our average chlorophyll concentration in all our lakes and ponds over the years from 1988 to 2012, this is kind of the overall average, and you can see there's been some movement up and down, but what really stands out is 2012. We had a much higher level of algae in our lakes and ponds, which is puzzling because we saw the phosphorus going down. And this is kind of an illustration where the science and the results always don't match each other. And so when I did a similar chart ranking all the lakes that we had, where we had monitors in 2012 versus the average, what you can see is, in contrast to the phosphorus, where there were very few lakes that had more phosphorus than their average, we had a lot of locations all across the board, from the very low algae lakes to the very high algae lakes. So we had a lot more algae blooms and a lot higher algae overall last year. So that is very puzzling and very concerning. And so one of the things we need to always think about is what's going on, what's causing this. And so it's always instructional for us to take a look at the weather. So this is precipitation. It's done on what's called a water year, which runs from October 1st to September 30th. So it's not a calendar year. It's kind of the year as the water bodies would be consuming and using the water. And so this is the normal precipitation. Above is precipitation above normal and below normal. So here is the floods of 2010. Here's 2006, which was another particularly rainy year, and 2012, which was a little drier year. But you can see kind of there is some variation between the years. It's not all higher, not all lower. It's kind of what has been predicted for the climate and the weather in New England. If you contrast that with temperature, it is really quite striking, because here's the normal temperature, our 30-year normal. This is for the Kingston weather station right near the University of Rhode Island. And if you look, you can see you don't have to you can look at it totally without your glasses on. You can see that the temperatures are very much above our 30-year normal. An absolute trend. I mean, we can all feel it too. We can certainly feel it this year. And in 2012, it was very high. So we had less rain, more heat. Perfect conditions for growing algae. And so what we've ended up, and Liz has talked about this, is we're ending up with situations where the weather we're seeing now is really conducive to growing cyanobacteria, also known as blue-green algae, which love warm weather. They love warm, still weather. It's ideal for them to grow, which is why often you can see them accumulate in the coves. And so this is some of the shots we have. They're taking them. And we expect this to be a growing problem in our lakes and ponds, and actually in some of our river systems, and something that really bears watching, such as Liz said, because the blue-green algae can produce toxins which can cause problems in pets, livestock, and people. And we're seeing an increased number of advisories that Liz Scott mentioned, and we really need to be aware of this. And what people ask me is, what should I do? I said, well, if it looks green and yucky, don't go in the water. But it's very interesting what we consider green and yucky here. Out in the South and in the Midwest, some of these people consider it fine to go swimming. So it's, when we have diverse populations coming in from other countries where they're used to more nutrient-enriched waters, we need to engage in a lot of education to make people aware of what's going on. So besides the advisories that DEM lists on lakes that are closed, they actually have some very good fact sheets on blue-green algae. And they worked very hard to educate the veterinarians throughout the state to be on the lookout for problems in pets. So I think it's great to see what Rhode Island is doing moving forward with this. So I also wanted to talk a little bit about bacteria, and after the seminar there's a test on the numbers here, so please pay close attention to them. Actually, what I want you to do is look at the colors and look at the red. And this is a shot of monitoring data from Watershed Watch during one of our water collections, which we have 6 each year from May through October. And this one happened to occur right after a significant rainfall. And what we do when we chart the data, and we use that same enterococci indicator that the Beaches program uses, is we put this up on our website. And if it's red, it means it's above the recreational standard. If it's black, it's below it. And so you can really see how in rainfall we see such a predominant of exceedances of recreational contact. And it really doesn't make too much of a difference if it's a rural community or a rural site or an urban site, because in many cases wildlife is being confined to a smaller corridor around our rivers and streams, and that's all getting washed into our waters. So in dry weather, our swimming areas are generally okay. We're not going to discuss spring lake in terms of this. But we do know that rain does increase our bacteria levels just about everywhere where we monitor. And so our take-home messages now are that algae blooms are increasing, water temperatures are increasing. What we've really noticed in we're in a project now where we're taking all our water temperature data over the last 26 years and pulling it all together to see if we can denote some trends. One thing I've noticed already is, at least on some of the sites, the minimum water temperature, the lowest water temperature during the growing season, is increasing. And we don't necessarily see a higher maximum water temperature, but we see a higher minimum water temperature. So what that also means is with the warmer water, there's more active biology going on. The growing season for the algae, for the plants, is longer, so we're going to see more accumulation and growth. As we know from everything we've talked about here, intense storms do increase runoff, and runoff is a major issue affecting all our water bodies, whether they're fresh or salt. Bacteria levels are high everywhere, and in many cases it's surprising and gratifying how resilient some of our water bodies have been to what's going into them and their capacity to absorb it so far. And just as one small plug for volunteer monitoring and professional monitoring too, is that the value of monitoring increases with each year. As one of my colleagues has said, you can start a research project anytime, but a year that you don't monitor is a year that's lost forever. Thank you.